Hello and welcome to this first video of normalization. It's going to be an easy one. We're going to go through the third normal form, but first of all, we need to understand the process of normalization, which is really the main idea behind it is to reduce redundancy and also to create a number of tables that can be linked based on certain type of relationships, whether it's one-to-one or one-to-many or many-to-many, which cannot be done automatically. It has to be broken down into one-to-many. Either way, we're going first of all to look and examine the report that we have in front of us, which is, we're going to call it sales report. This is an example I got it from www.w3computing.com. This is to give a credit, but it's not the exact data, or I modified it a little bit to make it a little bit more applicable to what I want. Also, the process of going over it is a little bit different from how they did it in the website. Anyway, this is the sales report, and I wanted to go ahead and examine it, that we need to build a database as a result of this one here. This is coming from obviously a spreadsheet. It shows me the salesperson here, salesperson ID, the salesperson name, and right away I could split out there is a problem with it. Maybe the name is misspelled. And also maybe the not maybe for sure that we have non-atomic data full name as a first and last name in one cell that is not encouraged. We need to break that into two pieces of data, first name and last name. We notice here in the customer number, we have a repeating group in the same cell or in the same entry. We have customer name, we have a 3 for each salespersons, and we have warehouse and warehouse location, and also we have the sales amount, which is also 3 amount pertaining to one entry that is not allowed in the database. So we first of all, let's go ahead and name, as long as we see some problem, what is required for us to move from this unnormalized database into a first normal form. We have a 3 requirement. The first requirement is to have no repeating groups. You know, that's basically all these data entry that has like Seguin systems in your Brownfields water and TLU. Each one of those must be set and separate cell by itself. And I'm getting Alt Enter to stay on the same cell. Number 2, all data must be atomic, meaning single value for each cell, not first name and last name. The third one is going to be, and which is the most important part, I think, is to identify a primary key for each record after we eliminate the repeating groups in the non-atomic pieces of data. Identify a primary key for each entry, let's call it row, and also record. So all those terminology is applicable in this case. So I'm going to go ahead and deal with this data. It's going to take us a long time to split this manually. So I'm going to go ahead and copy this one here and take it to Microsoft Word, and hopefully I'll be able to rearrange the data very quickly and move it back into Excel. So here we go. If we notice, this is misspelled here. So okay, just go ahead and leave it as it is. Salesperson, names, customers, we could leave it also and change it later, or change it directly if we want to have a better name. Okay, I'm going to go ahead and insert into the table, draw the table, and here hopefully that will make it easier for us to split those into actual rows. I hope this is going to work for us. Here we go quickly. Okay, that worked for 2 of them, but we could still go ahead and eliminate this one here. All right, that works. So we have the 3 now, and also I need to go ahead and do this for this one here. All right, so still we need to go ahead and break that into I don't feel like retyping everything. So I'm drawing actually a piece of data here and there. And now I could go ahead and move, go ahead and move this, copy it, basically copy the whole thing and bring it back to Excel. And I'm gonna go ahead and paste it, but I need still to eliminate all the data here. The same salesperson will be 1,000 and 1,000 here, and again at 3, 4, 3, 5. It's the same salesperson ID at 3, 4. I know I made a mistake. I'm gonna go ahead and fix it. 3, 4, 3, 5. And this person here, this person here, uh, is going to be, I'm going to go ahead and insert another row here. Basically, this is for first name, and this should be last name. Let's go ahead and change this to last name. So this is going to be Jamie. All right, and I'll leave this as a Smith. Since we have to, this the same person who did the first 3 sales. She has the same ID, so I'm going to go ahead and copy it using Excel feature here. The same thing here for Ty. And I'm going to go ahead and leave Johnson by itself right here. Okay, you notice here, and we're going to go ahead and click this as twice. The same thing for the sales area. I need to repeat that for everything. I don't want to, every row must be completely entered. And here we go. We don't have any more repeating groups. We don't have any non-atomic pieces of data. And we're ready to re-examine now what we should do in order to create a primary key for each row that identify each entry uniquely. If you take a look at the sales personal ID, it's a candidate, but since we are actually we already did that, we can repeat the salesperson ID, which we did here. As you notice, there is a repetition here right away. It cannot work as a primary key because the primary key must be uniquely identified and also must be non-null. I mean, it's not a null value. So knowing that is being repeated, I cannot use it as a primary key, but I might be able to look at additional piece of information that or data that is going to work with it in order to form a unique entry. Or maybe there is a piece of data that could uniquely identify each row completely, but I don't see any except the customer ID numbers can work with the salesperson ID together jointly in order to become a primary key, which is going to satisfy our need, knowing that those two entries together as a composite key or a concatenated key, they will work together in order to assure the uniqueness of each entry. So now I have a composite key, which is both the salesperson ID and the customer's number working as one primary key. And that assures me that the uniqueness of the primary key assures me there is no repeating groups. Also, there is no atomic data, so I could go ahead and move into the second normal form. The second normal form, no partial dependency. And the partial dependency here is to see, since I have composite key, the composite key for as a primary key, which is both sales person's ID and customers a number. So more likely we have some sort of partial dependency, which is in this case, we have to examine each one of those. Automatically, I could see that the first name of the salesperson and the last name of that individual, they're not dependent on the customer's numbers. They're only dependent on the salesperson himself or herself. Also, the sales area where those are located, these individuals, they don't have anything to do with the customer number. So the first thing I could do is to go ahead and take these these 6 rows and split them into another table, into another table, and I'm going to go ahead and put those into another table and paste it, of course. In this case, paste it. Let me first of all make sure that I copied it. Copy, and I'm going to go ahead and paste it. And if you notice, this table, which is, I'm going to call it salesperson. So I'm going to call this as the table salesperson. And notice now I could easily remove these two. Here we go. I could remove them because they're redundant. Since it's stable by itself, I don't need any indication of the data need to be left there sitting, and also confuse the fact that primary cannot be repeated in the second table that I just derived from the original table, which is the sales report. So also I have to repeat the same process by eliminating these two. And notice now we have a new table only with two names, with two entries rather, with Jamie's and but the last name is Smith in the sales area, but she has only one unique, and this is going to become my primary key for this table, which is the sales primary ID. What about this table? Of course, this table here, we're going to remove those since we already got rid of those. So these three record here, I'm going to be able to remove them. In this table, in the second normal form, I'm going to go ahead and copy it and rearrange. Okay, copy this, and of course go here and paste it. Okay, and the first thing that I need to do is to go ahead and maybe move this here a little bit by these two tables. Here we go. We're going to go ahead and delete that. Delete it. Okay, and shift those one here. Okay, so we did shift it. No big deal. We deleted those, and we still have the person ID because that's part of the original primary key. And we have the customer's name, the sales area need to be deleted as well. I forgot to delete it, so I need to delete it as well. So it's going to be done. And notice now we left with the salesperson ID, customer number, customer's name, warehouse number, the sales warehouse location, and the sales amount. If you notice now, still that those original primary key, if you take the customer's name and the warehouse numbers and the warehouse location, those are only dependent at this moment on the customer number. And the sales amount, be careful here to what I'm going to say, the sales amount is really dependent on both the sales person ID and the customer numbers. So since the customer name and the warehouse number and their location only dependent on the customer ID, I have to split this table here by taking those data, and since they are partially dependent on the customer number instead of both customer number and salesperson, I'm going to copy this. I'm going to copy this and put it right here next to this. Put it next to here, and notice now since no customer numbers is really repeated, so I could easily leave it as it is for now, and I'm going to call this customers table, customers tables, and this one here, since we removed those, we're going to take this three here, delete them, and notice it's going to really be only this one here, the sales amount. Let's go ahead and put it in dollar figure here, depending on both of them. So this is still is the sales transactional or transaction table. We're still original. And notice that both the salesperson and the customer number is going to be acting as a composite key, and that identify which transaction, okay, in table, and which person really did what did sales for which customers and their sales amount as well. So this basically everything here is completely dependent on the salesperson ID. It is already in the second normal form, and this sales amount is dependent on both of those two pieces of data here, salesperson ID and the customer NMB, it is already on that second normal form. There is no partial dependency on this because sales amount dependent on both. And customer's name, warehouse number, and warehouse are located depending on the customer's number because the customer is going to pick up the item that they bought from a specific warehouse. Now, we are completely dependent on one piece of data, which is the customer number, which is acting as the primary key for this table. So we are completely in the second normal form, and there is no partial dependency. The next move now is to go into looking on what we have for the third normal form. What is the third normal form? No transitive dependency. And the transitive dependency meaning what? So non-key, meaning any other key other than the primary key, is dependent on another non-key. And we're going to go ahead and see if that is the case. No non-key is dependent on the another non-key. And we're going to go ahead and look at this closely and see if that is the case. In this case here, I don't have a composite. We already dealt with the composite key in the first one. First name indeed is dependent on the salesperson. Last name is dependent on the salesperson. Sales area is dependent on it. It's only a single. There is no last name and first name, both of them dependent on the salesperson, i.e. the same thing as the sales area. So there is no transitive dependency in this case. And since this is only one item here, the sales amount dependent on both of those piece of data that acting as a primary key, so there is no transitive dependency because we don't have any non-key, any other. For example, in sales amount is the only non-key value that exists in this table, so there is no transitive dependency because there is no two non-keys to really look at. And now here we're taking a look at the customer names and warehouse and the warehouse location. We want to see if these are three, as any of those is dependent on each other. Of course, warehouse is not dependent on the customer's name, which is, and in this case, warehouse location, however, is dependent on the warehouse number. So since this is here, non-key field is dependent on, we're going to go ahead and make it red here, non-key field, which is dependent on another non-key field. Therefore, we have to do something about it. We have to split those, take this one here and act on it as a third normal form by splitting this. It's going to cause a transitive dependency. It's going to, for example, I could easily misspell this one here by saying this is larger north instead of leaving it. So it's going to cause some sort of anomaly, whether it's insertion or deletion or updating anomalies. Like, for example, no, I updated this, but I didn't update this to be the same thing. If I deleted this one here and left the other one and delete it, so all sorts of anomalies will be caused by the fact that there is a transitive dependency on each other. So what are we going to do here is, first of all, to avoid this type of anomalies, I'm going to go ahead and take these and cut this actually. Let me go ahead and copy it, then I'll do it better. We're going to go ahead and paste this one here for now, but this one here has to be deleted completely. Okay. We're going to go ahead and delete that. We don't need it anymore because we have now the warehouse, and this is another table. It's going to be a warehouse table. Okay, you could call them all transaction table, customer table, and we could also call that the first table, person table, salesperson tables. And as we notice here, if you notice here, we're going to go ahead and say south side is number, let's start with number, if we say it here, number 4, We could leave it, Plymouth is number 2233, no big deal, as long as we have now this table is linked to this table. So this is the primary key. This is the primary key. Okay, and this is going to be that the only non-key table in this one here. In order for me to link those two tables, notice here, this is going to be a one-to-many relationship, and this is the one, the warehouse is the table in the one, and obviously we have the many relationship in this case. As you notice, I need to go ahead and clean this first. I'm going to clean this one here because this already has number 3. Delete it. And I need to delete this as well. And I don't have anything repeated except those 1, 2, 3, 4. So I need to change this to large or north or large, whatever. And I only change it one time. So it's not going, the only thing that I have to bring to here is the number 2, which is really the primary key for the warehouse, which has become the foreign key for this table. How the other tables are linked together, notice this table is going to be linked with the transactional table, and also the salesperson is going to be linked to the transaction table. The transaction table is going to be the junction table between the salesperson table and the customer table. This is going to be the 1, and this is going to be the 1, and these are going to be the many for the salesperson ID, and this is going to be the many for the customer's number. And now my database is normalized to the third normal form. Again, the third normal form is to eliminate the transitive dependency where non-key is dependent on non-key. And to go back, I'm going backward in my explanation here to remind you of the second normal form, no partial dependency, and the first normal form is no repeating groups. All data must be atomic, meaning single value in a cell. And of course, you need to identify the primary key for each entry in row. Thank you for watching. I hope you enjoyed this. Watch it over and over, and hopefully you will get the normalization process. It's not that difficult if you really take your time.